Hello everybody, my name is William Lee. I am a sales engineer at New Relic. Today's talk is going to be about APM, which is Application Performance Monitoring. If that's not what you're interested in, you still have time to escape right now. So what is APM? So APM stands for Application Performance Monitoring. It is kind of a descriptor in itself. We monitor the performance of your application, show you the baseline as well as where the bottlenecks are, what's causing any slowdowns, and then being able to break it down into its individual components to show you what could be actually causing the issues that you may be seeing. So what we're going to do today is very quickly go over how New Relic functions and then go through the dashboard to show you examples of how to actually find issues within the code itself and how to use that information to not only be able to see where the problems are, but also be alerted if the issues come up so you don't have to, have someone monitoring that big dashboard on the TV screen at all times. So New Relic, we start off very small, working only within Ruby, expanded very quickly into Java, .NET, as well as Python, servers, and now Node.js. So those are all the languages that we monitor on the web application side. And the way that we function is basically by actually installing a bit of an agent into the application server that you want to monitor. What that agent does is it actually recognizes the transactions being processed by the application, uses that information to then see how long it takes for the transaction to complete, and then break down the components into its constituent parts. We start off on the APM side, but have very quickly moved over into other products. So now we are also able to monitor the performance of your native mobile applications, actually able to look at the servers or the hardware that powers your software to see any performance issues there, even going all the way over into your browser to see the performance from the end perspective of your users. We're also able to bring all that together into what we call our Insights product, which is actually gathering all the information so you can use analytics on the data that we capture. This is also buoyed by the use of our platform, which is our plugins that allows you to monitor components that we typically do not have access to, such as your NGINX servers on either the reverse proxy side or even the caching side. How does it technically function? Well, the agent that sits on your application server uses either bytecode instrumentation or monkey patching to actually look at the transactions and to time them to see how long they take to complete. That data is collected and then sent to our servers once per minute, so a very classic SaaS solution. Once it's sent over to us, we process the data, then serve it up for you, and all you need is is a browser as well as an internet connection to see it work. So if there are no questions, we can then go just jump directly into the dashboard. Let's see if we can zoom in a little bit on there, make that a little less of an eye strain. Looks like something out of 1995, but that's all right. So the dashboard we're looking at here is on the APM side. The main chart that we're looking at is the web transaction response time. Before I go any further, the information we're looking at here is Streama. Streama is one of our oldest customers. From a security standpoint, I just want to let you know we are only able to show you their data because they've given us explicit permission to do so. Now, what we see here is on the chart a breakdown of how long it takes for a transaction to complete on average. You can see that on the top right-hand corner, it tells us that it takes about 86 milliseconds for transactions to finish. And then within the chart itself, we're able to break down the transaction into its constituent parts. So here we have time spent either in the request queue, in Python code, database calls, memcache calls, or external web calls. This serves as sort of a baseline for how your application typically performs. And from here, we can then delve deeper into the transactions to see how long, or to see what makes up that larger average number. So for example, if I want to switch over into this histogram view, I can do it simply from that drop-down menu. Oh, might have to reload here. There we go. All right. So what this histogram view is going to do is it's going to actually bucket the transactions into specific performance profiles. So you can see here about 12% of the transactions take about 0 to 10 milliseconds, 27% in the 10 to 20 millisecond range, so on and so forth. Now, what is the importance of this? Well, if we look at this, we see that the vast majority of the transactions will finish before 30 milliseconds. However, switching back into the average view, we're reminded that it takes about 86 milliseconds on average for the transactions to complete. So where does that discrepancy come from? Well, if you follow this long tail of slow transactions, that's really where the issue lies. You can see that the transactions themselves, although are not very numerous, because they take so long, these are the ones that are going to be taking up far more resources than required, as well as causing your end users to be waiting for a response form from your application. So what's interesting about this is that we can easily click into any of these transactions to see what actually makes up that specific bucket, right? So this way we can actually see the differences between a transaction that takes between 10 to 20 milliseconds and one that takes over 300 milliseconds in this standpoint. So Streama, just want to let you know, is a little bit of an outlier. For most of our clients, the graph does not look anything like this. What you'll see is more of a typical bell curve. Streama, because they have been a customer of ours for so long, has actually optimized theirs so that the vast majority of the transactions are very, very fast. So that's sort of where we want most of our customers to be, is to be able to get to this point where they can look at this and say, okay, we're performing pretty well across the board. To the right-hand side of the web transaction response time is your AppDex score. So your AppDex score stands for your Application Performance Index. This is actually a fairly large part about New Relic, so just going to spend a minute here to explain what it is. Application Performance Index is basically a way for you to easily calculate a number that represents the performance of your overall application. So the number is represented here in this 0.98, and that number is going to range between 1 and 0. 1 being a perfect score, which means all transactions have finished successfully. 0 being on the other opposite end of the spectrum, which means none of the transactions have finished successfully. So what this score allows you to do is, one, at a glance show you how your application is performing, but two, this also powers our alerting system. So that's why it's so important to be able to set an AppDex value that's important to you, so that if we ever drop below that threshold, we're going to send you an alert that is also meaningful and that you understand is in fact a call to action for the performance side of your application. Below that, we just have a throughput, which shows you the number of requests per minute coming through the system. And then at the very bottom, a list of transactions. These 5 are the slowest ones, so just very quickly giving you an idea of what you need to focus your time on, and then a snapshot of the servers that are actually powering the software. So this basically serves as a way for you to just get an overview of the application from a very, very mile-high perspective. From here, we can then jump deeper into the application itself to see what's going on in the actual app. And I like to do that by going into this map view. What this map view is going to be able to do is actually give you a visual representation of the external dependencies on your app. So in the middle is the application we're currently looking at, and to the left and right-hand side are those external dependencies. Anything that shows up on the left-hand side, these are components that are making calls to your application, whereas anything on the right-hand side, these are components that are being called by your application. So that's why you'll see the database, memcache, different API calls will show up on the right-hand side. Clicking into it will give you a graph of the response time of the specific components, as well as how often the component is called. So therefore, giving you a larger environmental view of your app. Once you have this view of the application, we can then start drilling deeper into the transactions which are interesting to you. So before going into this, let me explain what we actually mean by a transaction. So it's actually a little bit of a nebulous definition from our standpoint. A transaction basically begins when an HTTP request comes into the system and ends when that request has been fulfilled. Reason that it's so generally defined is simply because a transaction could be many things depending on the complexity of your site. If it's a simple static page load, that in itself could be a transaction. If you take, for example, an e-commerce site, there could be multiple transactions going on for every single page load. So for example, the first thing that's going to be checked is my credentials to see if I am who I say I am. That's one transaction. Pulling a product information, that's another transaction. Getting related products, that's another transaction. So each one of those is a separate request and a separate reply from the server itself. Now, what we have on the left-hand side here is a list of all the different transactions that we are tracking for you. By default, we're going to be listing these based upon how much time is consumed per transaction. So the slowest ones are going to bubble up to the top. You can filter it through a few different manners, either slowest average response time, AppDex most dissatisfying, or highest throughput. Now, once you've chosen a transaction that's interesting to you, then we can click into it. And this is really the bread and butter of what New Relic is able to offer. By clicking into that transaction, what we're going to get is, excuse me, a visual representation of where the time is actually spent in the code, right? Is it actually the application code? Is it the database calls? Is it the calls out to memcache? Whatever components you'll use, you'll have a visual representation of the time spent in each component here. You'll also have the capability of seeing how often it's called and a breakdown table that's going to list all the different components as well as what segment it belongs to, percentage of time spent in that component, how often it's called, and average time spent in it. Now, this information in itself is very useful, and it actually does help a lot of our customers already get to what they should be focusing their time on to optimize for their application. However, from our perspective, this is still aggregate level data. What that means is the numbers are crunched for all transactions of this type. If you wanted to get deeper into that, we can actually use what we call these transaction traces. So these transaction traces are individual instances of the transaction. More importantly, they are slow individual instances of the transaction. So when the agent sees that one of the transactions is taking longer than normal to complete, it's going to automatically take a trace of that transaction. And in here you can see when the transaction occurred, how long it took to complete, a visual summary again of the transaction. So this shows you where the time is spent in the code, a listing of all the different components, how often it's called, duration of the call, percentage of time spent in it, as well as other data that could help you debug the situation, such as the actual URL and any custom parameters you want to send over. And even better, if you click into this trace details, this is going to give you the actual code path for the transaction, showing you every single function call, every database call, every external service call, and the exact order that they actually were done in. Now, the names here are a little bit scrunched up, so it's a bit of an eyesore to actually try to decipher that. But what I wanted you to focus on is the fact that we actually have this drill down category. So this is something that I especially like. If you see an icon in the drill down category, you can click into that for additional details. So for example, this database icon, by clicking into that, it's actually going to show me the exact SQL query that was run for the transaction. Therefore, already showing me what I should be spending my time on to optimize. If it is in fact the database query, I can then go in there and see, okay, what's causing the slowdown, what table is being accessed, what exactly is going on in here. All right. Another incredibly useful feature for our end users is what we call a key transaction. So imagine a transaction that if it were to ever slow down would mean it's going to affect your business, right? So very simple example again for an e-commerce site. If your checkout transaction doesn't work, you're leaving money on the table, you're not able to, your end users are not able to check out, but most importantly, if they wanted to, that's a possibility for them to go to another site to buy what they want. So what a key transaction allows you to do is basically separate that transaction from the rest of the application, so therefore giving you individual monitoring of that one transaction type. The most important part about that is, again, the alerting system, which is tied to the AppDex score. So the key transaction has an individual AppDex score that you can alert on. That way, you will know exactly what you need to actually react to. But even better, if you wanted additional details about that key transaction beyond what we offer in the transaction trace, you can actually click into this X-ray session. So what an X-ray session does is it basically combines the transaction trace we saw before with a traditional profile view of that transaction. So when you run an X-ray session, it's going to split up 100 transactions, and while it does each one of those 100 transaction traces, in the background, it's actually going to run a traditional thread profiler to get you down to the actual code level of what's happening within that specific transaction. So that means not only are we going to be able to tell you specifically what file is being used, but also the function and even the line number in the code and how much time is being spent in each and every one of those components. So this is especially useful for those type of nitty-gritty questions where you just can't figure out specifically, what's going on, where is the time is being spent, and why is it actually being spent in there. By running one of these X-ray sessions, you'll be able to get down to that level of granularity within your system. All right. A few other very useful features for our end users is the use of our deployment system. So the deployments you can actually see will show up in the chart as basically these teal markers. And deployment for us is basically when any change in the system actually occurs. It could be something as simple as a code push. It could be if you had updated your OS, if you had changed, added another server into the system, anything that actually has happened, you can use deployments to track that information. And what we'll show you is how that deployment has affected the overall response time and load of your system, the aptX score of your system, how much of the CPU has been utilized, physical memory utilization, as well as database utilization. So that's on the resource side of things, showing you how much resources or how the resources are being affected and whether or not you have ample resources to handle the load on your system. The other great part about this is our change report. What the change report is going to do is it's going to actually gather the top 10 transactions in your system and show you how those transactions have been affected by this deployment. So showing you whether or not it has increased the throughput of the system, decreased the overall transaction time, average transaction time, as well as the aptX score for your system. So again, really showing you whether or not the changes that you have made to the system has positively affected the overall transactional speed of your web app. All right. Another very useful feature is the use of our scalability option. So what this report is going to do is actually show you whether or not your system accurately handles load. So here we can look at the overall response time, database, and CPU responses to load on the system. So on the x-axis is load, so number of requests per minute. And as the load increases, how does that change my overall transaction times on the y-axis? So you can see all these dots represent a different hour of the day. And we can see for Streama, they have highly optimized their application to the point where this graph actually looks a little bit strange, which is as the number of requests increase, they've actually been able to get more performance out of their system. Again, a bit of an atypical situation and not what you would normally see for our clients. What you would typically see is a symmetrical, not a symmetrical, increase of the response time. But what you want to avoid is any type of exponential increase or extra linear increase, which basically means something is either not right within the architecture itself or not enough resources for the load that you're actually seeing. So we can look at this from the overall response time or break it down into components such as your database or your CPU. And I'm sorry that I'm kind of speeding through everything. We started a little bit late, and there's just a lot of really cool features that I wanted to show you. So if there's any questions or anything, feel free to just jump in at any point. So what we focused on up to this point has been on the application side. As I said before, we do have a lot of other products which will help you save time getting to the mean root of any performance issues you have. And one of those that I really like is actually the use of our browser monitoring. So the browser monitoring actually is able to check the performance of your site from the vantage point of your end user. What I mean by that is we're actually able to see the page load times from the end user's browser. And the way that works is we have the capability of injecting a little bit of JavaScript directly into the HTML that's served to your end user. And that JavaScript is going to give you performance information as well as some of the advanced features that you may be using, such as AJAX or JavaScript errors. So for your front-end team, this is going to save them a ton of time into figuring out what's causing any performance issues on your end user's browser. Now, the reason this is so important is because if you look at this graph here, what we can see is that there's a distinct delineation between front-end time versus back-end time. So back-end time is time spent in the request queue, web app, or network, whereas front-end time is time spent in either DOM processing or page rendering, which is time actually on the browser. For Streama, they are a music streaming service, so this time it actually takes to create the page on the browser, which is the DOM processing and page rendering portion. That is somewhat more acceptable because an end user understands that a page actually needs to load, the player needs to load before they're able to listen to their music, so they're a bit more acceptable of the high page load times. But for other types of situations, be it banking, e-commerce, travel, hospitality, if you have a 10-second page load time, no one is going to sit around and wait for that page to load, right? So that's why it's important to not only be able to see how the back-end responds to requests, but also how front-end actually creates those pages. And so, as I said before, we're able to give you a lot more performance information based upon the information that we have here. So, for example, if you wanted to look at specifically how the browsers stack up, the performance of the browsers are shown to you here, so you can click into any of those. So everybody's favorite, IE, of course, it's going to cause an error right away. So you can click into any of these, and what it's going to be able to show you is the actual number of versions. Okay, so it's not going to be able to show me that right now. Sorry, we're running off of our staging stuff, so the front-end team tends to be cowboys. They push releases as often as they want. What I'm going to do is actually switch over into this server to maybe show you a little bit more. So it's got for the browser portion, that's going to give you demographic information related to what browsers are coming into your site, what versions of those browsers, as well as the performance of those. That and the geographical portion are pretty much available to you on Google Analytics as it is, so it's not terribly interesting. The portion that I like is the use of either the AJAX or the JavaScript errors. So AJAX, we're actually able to track the different AJAX calls hitting your backend, as well as any API services you're using, and be able to show you where that time is actually being spent. So for example, if I'm going into this accounts AJAX call, it's going to show me a performance breakdown of where the time is spent, be it the application, callback, network, or queue time, how often it's called in the throughput, status codes, which is whether or not it's successful, and average data transfer per request. It's especially useful simply because as the number of AJAX calls increases, it's almost like you lose track of them since there's so many different elements being opened up on a page. And it only becomes an issue if the entire page doesn't load. If one of those widgets or one of those graphs doesn't load, most users won't even notice. So having this automatically be able to capture the performance of that will show you whether or not they're performing as you feel like they should. On the other hand, JavaScript errors is a bit more of a major issue. So in here, what we have is the capability of actually tracking how many errors are occurring and showing you what's causing those errors. So here on the left-hand side, we have a list of all the different errors that are occurring, and we can click into any of these, and what it's going to show you is how many page views have that error, the total error rate, a browser breakdown of what browsers cause this error versus all errors in general, and the best part is the error instance details, which is going to give you an actual example of that error, including what message was thrown, the exception type, when it occurred, the URL it occurred on, browser used, user agent information, as well as a stack trace of that error. So for your front-end guys, this is going to save them a lot of headaches simply because if you've ever had to track down a JavaScript error before, it is one of the most painful things you've ever had to do in your life, and having to recreate it to see how it was caused is next to impossible since it's almost impossible to actually recreate the exact environment that it was created in. So having this automatically available for our end users is incredibly, incredibly valuable. And the best for last is actually our session traces. So this is actually something we released just last week at our user conference, and this is a really, really cool feature because what it actually allows you to do is see a full example of a page load and even the interactions on a page from, again, the perspective of your end user. So what that means is we're able to see every single thing that happens on the page, including the actual interactions, basically the user's clicking on that page. So there's a ton of information here, so I'll actually break it down bit by bit. The first portion is the URL that it was actually accessed, the browser used, when it occurred, how long it took for the initial page load versus how long it spent for the AJAX after that page load to complete. Now this is actually an important distinction because for most modern pages, what happens is the first page loads, and then as soon as the page is complete, all these AJAX calls go off in the background, pulling in a lot more content onto that page. Now, typically for a lot of browser analytics, what happens is after that initial page load finishes, that's where the analysis ends. For us, because we're able to track that entire interaction, we're able to get you all that information, including that AJAX information. First interaction, which is when the user actually either hovered over an element that caused rendering on the back end, or else when the user actually clicked on an element, and the full duration of the call. Now, that's just the staging information. Below this is the actual real meat of this. First of all, we have the capability of showing you the entire trace. So on the top end is the slider that you can choose for what duration of the call you want to look at. And then there's a heat map of where the time is actually spent in the browser. Is it loading up assets, which is the green portion? Is it loading up AJAX calls, which is the orange portion? Or is it the actual interaction, which is the purple portion, showing you users clicking into the page? The blue portion is actually API calls made through the API timing element of the browser. And then below that, we actually have specific stages of the page load, including time spent in the back end, DOM processing, page rendering, as well as time waiting on AJAX. So if we actually go through this, what it shows us is the full session for that end user of the page load. So every single AJAX call you can see will show up here, as well as how long it took for the AJAX call to complete. Every single load event, every single mousing reaction, which is the actual interactions by the end user, is going to show up here. Therefore, giving you a much broader view of what's actually being used on your end pages by your end users. All right, so I know sped, again, through a lot of different things here, and I did want to leave a little bit of time in the end to answer any questions, or if there's any issues or anything else that someone wanted to bring up, I'd be happy to answer those. Yes. Good question. So it is 100%. What happens is we are able to use the 100% to give you a broader baseline view of what's going on, and then we pick specific either transactions or interactions that we want to focus on, most likely the slowest ones, to show you what's actually happening in them.
And then for the slowest ones, I guess you don't really know ahead of time which ones are slow and you have the entire thing for. So you
Right.
thresholds of some sort of thing you can set. Top 1% slowest or something.
So that's
Scalable on a track.
right, right. So what happens is there is a setting that you choose, basically saying this is what I consider to be a slow transaction, right? At which point we are actually, in fact, tracking every single one, but the ones that are obviously finishing very quickly, we're just going to throw those away. Therefore, we only show you the ones that meet the criteria that you have set.
Okay, so it's really threshold rather than number. It's really they're crossing some pre-defined threshold.
Yeah, exactly.
The previous talk was about WebSockets. If you launch your WebSocket.
WebSockets, I don't believe, are currently.
Because that basically part of the argument with that one is that obviously for highly interactive things, you want to have WebSockets support AJAX, but obviously AJAX is really relevant still.
Right.
Okay. We have one more, please. How much does loading your probes perturb the data? I'm sure you try to optimize that as low as possible, but I wonder if you have a better measure of that.
Yeah, so on the APM side, which actually on the application server, the performance hit is going to be about 2 to 3%. And then on the browser side, which I showed you, it's going to be actually less than 1%.
So you just basically make sure that those probes are very, very lightweight.
Yeah.
You're always running 100%, so you're always paying 100% of that times the weight. And then when you mentioned that you moved to server as one of the things you could see within Node.js, what is servers?
So servers is actually tracking the hardware. So Node.js is another language. So we have the capability of tracking different web applications that do use Node.js.
Well, what does the server mean? What are you looking at for a server? Well, that was just one of the features you showed. You went to start Ruby, Java.
Oh, right, right. So for server monitoring, for the hardware side of things, we're able to track basically the hardware resources in use. So basically CPU, I/O, memory, as well as disk.
Okay, so you get the same things you might get from any of those tools.
Right, right. Exactly. The reason that we found that the server monitoring is actually really important is because, well, I'm pretty sure we've all seen this before, which is, okay, the website is slow or stopped responding. We call IT, tell them, hey, the servers something's wrong with them, fix it. Where realistically, most of the time, it's not like a server is going to not go into work one day, right? It's, in fact, the software that usually causes most of the issues. So therefore, this is a quick sanity check for our end users to see, okay, is the server up and running? Is it, in fact, constrained by resources? Or is it, in fact, humming along fine, in which case we can just sort of eliminate that as a core reason for the issue.
Right, so you detect some of this was caused because of this hardware problem, which is another way to filter it.
Right, exactly. Yeah, yeah. Any other questions? Yes. Absolutely. So great question. An aptX score is actually configured based upon this little number that you see here in the brackets. So that number is basically what you deem as an acceptable amount of time for a transaction to finish successfully. So by default it's 0.5, which is half a second. So for me, that means any transaction that finishes in half a second, I say that's a good transaction. That's going to positively affect my aptX score. Any transaction that takes longer than half a second, bad transaction, negatively affect my aptX score. Absolutely. So we definitely recommend our end users to configure it to something that's representative of the performance of their app. We don't want you to set it too high or too low. If you set it too high for like 10 seconds, yeah, you're going to get a great aptX score, but that also means if you have like a bunch of 9-second page loads, you're not going to be alerted by it because it's still below that threshold. On the other end, if you set it too low, that means you're going to be getting emails or PagerDuty alerts or whatever it is at like 3 in the morning for no reason. So set it to something that's representative of what you actually see in the performance of your app. Okay. Any other questions? All right. Thanks, guys.